Real camera work. Excellent. Right, question 7. The diagram shows the velocity time graph for two particles at and b which move on the same straight line. The units of v and t are meters per second and s seconds, respectively. Both particles are at the point s on the line where t is 0. Good. Right. The particle A is initially at rest. There's particle A initially at rest. And moves with acceleration 0.18 t meters per second until the two particles collide when t is 16. So this is the point where the two particles collide. The initial velocity of b is u. There it is. And it has variable acceleration for the first 5 seconds. There you can see its variable acceleration curve. Then it travels with constant velocity of 9 for a period of time for 10 seconds. And finally it moves the deceleration for 1 second before the collision. Calculate the value of t at which the two particles have the same velocity. The value of t at which the two particles have the same velocity. Okay, where do they have the same velocity? Well, that's on our diagram, isn't it? There you can see, let's do it with a little highlighter. Same velocity. There, that's the point that we're looking for. We're looking for what's going on at that position there. Right, well, let's see what we can work out with this. What do we know, what we've been told? We know that if we think about particle A, A has an acceleration of 0.18 t. I think if I'm going to solve this this equation here, if I'm going to find the time when it's at that point, one thing to start with, what is the velocity when they have the same velocity? It's 9, isn't it? That's the nice bit about it being the bit of constant velocity for the other one. We're looking for the value of time, the value of t, when A has velocity of 9. That's its acceleration. To get its velocity we need to integrate. The velocity is the integral of 0.18 t with respect to time. To integrate we add 1 to the power and divide by the new power. That gives us 0.09 t squared. That's 0.18 over 2, t to the 2, plus c. We need to work out the value of c, but actually this is quite straightforward, isn't it? Because when the time is 0, the velocity is 0. T is 0, v is 0, therefore c must also be 0, and we're left with the velocity as being 0.09 t squared. That's the velocity of A. That is the equation of this graph. It's a quadratic curve, 0.09 t squared. Great. We want to know, remember, when they have the same velocity, so if v equals 9, we're left with 0.09 t squared being 9. So t squared is 9 divided by 0.09, which is 100. So t is 10 seconds. And there is our first 4 marks. It was all about the integration, wasn't it? So it's quite straightforward 4 marks. As long as we got our integration right, we were there. For t between 0 and 5, so there's this first bit of motion here, the distance of b from s is given by that equation. Calculate u and verify that when t is 5, b is 25. Right, so this is our displacement formula, isn't it? This is x. This is for particle b. X is ut plus 0.08 t cubed. We want to find the value of u. U is the velocity, so we now need to differentiate. The velocity of particle b is dx by dt, and dx by dt, if we differentiate ut, that would go to u. If we differentiate 0.08 t cubed, that's 3 times 0.08 times t to the power of 2. So we've now got our velocity equation for particle B, and what else do we have to go on with this? We know that when t is equal to 5, the velocity is 9. So that means 9 is u plus 0.24 times 5 squared. That's the point that we know about in this question. If we rearrange that equation, that gives us, what does that give us? This gives us 6, so 9 is u plus 6, so u is 3. I've slipped from being a capital U to a lowercase u, but that's, you get the point. That capital U that we're looking for is 3. And it also said, verify that when t is 5, b is 25 metres. So, if u is 3, that means x is 3t plus 0.08 t cubed. And when time is 5, x is 3 5s plus 0.085 cubed. And that gives us 15 plus 0.08 times 125 is 10. So x is 25 metres as required. That's what we were meant to verify. Oh, we've done it. Last part of the question, just time. Calculate the velocity of b when t is 16. Right. Well, this is all about us piecing together the two things that go on. We're told that when t equals 16, the two particles have travelled exactly the same distance. So let's start by working out how far particle A has travelled. Particle A, so this is part 3. At t equals 16, same distance travelled. And particle A, that distance travelled is the area underneath the velocity time curve. And the area underneath the velocity time curve is the integral from 0 to 16 of its equation, which is 0.09 t squared with respect to t. So we're back to integrating again. That is 0.03 t cubed from 0 to 16. And if we sub in our numbers there, we get a figure of 122.88 metres as being the distance that A has travelled. Right, now B, so that means, remember, that means the area underneath that graph is that figure. B is broken up into these 3 portions. And we now need to work out the total area under the curve for B, because it should be the same thing. So, for B, well, let's think. For the first 0 to 5 seconds, the first 5 seconds, it travels 25 metres. We found that out. We were told that, even if we didn't find it out. We were told that in part 2. Between 5 and 15 seconds, it's travelling with constant velocity. Its constant velocity was 9, so it's doing 9 times 10, 9 metres per second for 10 seconds. That is 90 metres. So in that very final bit of time, we've got it going from 15 up to 16. We can now work out the exact distance that it travels in that period of time. It travels 122.88 minus 90 plus 25. So it travels a final portion of 7.88 metres in that last little bit. And all that's left for us to do is to work out the velocity. Now that is constant acceleration, isn't it? It's a straight line. We're told it's constant acceleration, it's constant deceleration. That means we're allowed to use Suvat. So we're back to using Suvat equations again. We're saying in the final 1 second, using s equals a half u plus vt, we've got that it travels 7.88 metres with an initial velocity of 9, a final velocity of v, and it does it in 1 second. And if we rearrange that equation, we get big V is 6.76 meters per second. And there we go. That is the end of the M1 paper.